Good afternoon, everyone, and thank you for joining our webinar covering online rheology and why it's important to everyone that processes polymers. My name is John Biagioni, and I am the president of Dynisco. Dynisco has more than 6 decades of commitment to helping customers provide a true window into the process, with leading-edge quality products and solutions for indication and control critical plastic process measurements including pressure, temperature, and polymer rheology. Harnessing these critical parameters allow the plastics processor to reduce lot-to-lot variations, reduce scrap, improve productivity, and integrate recycled materials into their process without sacrificing product quality. Dynisco sensors, controls, and analytical instruments have proven to offer better control, reduced downtime, minimum scrap, and unmatched reliability in working life. Today I will speak about what's going on in the polymer markets and the key drivers for North American growth. Bill DeRoges, Dynisco's Vice President of Business Development, will cover the range of rheological instruments that Dynisco has, how they are used by different end users, and why it's important for each of those end users. John Cazzotti, Dynisco's Director of Engineering, will talk about the specifics of online rheology. He will also cover specifics on Dynisco's new ViscoIndicator, which brings a new level of ease and lower entry price for the rheological market. So what is driving the need of polymer rheology today as opposed to yesterday? We will explore that over the next few slides. First, I would like to point out that what you see today is also what our employees see. Understanding the growth cycle within our markets allows Dynisco to address the needs of the customers and understand how to ease customer pain points. It was little over a year ago when Dynisco's leadership team saw a convergence of events creating a large market opportunity for rheological instrumentation. Based upon that need, we created the ViscoIndicator, understanding that we had to drive simplicity into all aspects of its design, operation, and feedback for users that currently do not use other online rheological tools. In the next few slides, you will see how sustainability initiatives, the reshoring of work, and the shale play are dramatically increasing the creation and use of polymer in North America. You will notice that I start with sustainability versus recycling. Why do you ask? Because where recycling was used specifically for economic advantage, sustainability is being used to address all aspects of the product life cycle. In general, recycled materials would cost less than their virgin material equivalents. Today, it's not just about cost, it's about the zero waste zone, repurposing all plastic items produced with the goal of zero landfilling. When we look at the current momentum in sustainability initiatives across the U.S., it has become obvious that the use of recycled content is on the rise. This includes both post-industrial recycled materials where the title of the plastics is known, and the usage of post-consumer recycled materials where the title is unknown. In both instances, the increase in recycled content impacts the rheology of the polymer used in the process, leading to impacts in the molecular weight of the polymer, ending in processability changes. Understanding how the melt flow changes impact the usability of the end product, allowing you to go back and adjust the mix of additives you are putting into the extruder. The second pillar impacting the increase in polymer production and conversion revolves around what we call today reshoring. Some people call it right shoring. Others call it regional manufacturing and distribution. Here at Dynisco, we have a strategy of build where you sell. By doing that, we minimize risk factors in the total cost of ownership while providing the quickest deliveries to our customers. Simply put, American corporations' love affair with chasing low-cost geography labor has been challenged lately by the actual results it has been receiving from that strategy. More and more companies are deciding to follow Dynisco's lead and build inside of the geography of demand. For today's discussion, that's North America, and with work returning to a quote-unquote higher labor rate geography in relation to Asia, productivity and quality become paramount. We simply cannot afford to make mistakes, driving the need for better sensing and rheological solutions. The third and the largest impact on polymer production for North America is the shale play. North America is moving from the highest cost producer of resins to the lowest cost producer of resin. Why? Because the two largest cost components of resin production are the feedstock and the energy to convert that feedstock, both of which are converting over to natural gas extracted from the shale fields. The next highest cost component of structure is transportation, so we envision a good portion of the polymer produced will be diverted to local secondary operations, whether it be compounding, injection molding, extrusion, film, or thermoforming. All will require an understanding of the rheological properties of materials you are working with. As you look at the graph from the American Chemistry Council, you can see the almost parabolic growth of the plastics market space in North America. What I can tell you today is that it is beginning to happen, although it has shifted 18 months, so we're effectively sitting at the beginning of 2015. This is mainly due to the dramatic oil and gas price drops, leading to a slowdown in capital outlays. The takeaway is that your company will be impacted by the polymerization of the U.S. as the available markets for plastics markets increase tenfold over the next 3 years. As we look at the almost $50 billion market opportunity developing over the next 5 years, the need for the associated rheological equipment will scale accordingly. This includes the verification of inbound materials against specifications such as melt flow index, melt flow rate, and viscosity. As materials are compounded and converted into secondary forms, more testing will be required to ensure master batching and physical end-state properties, driving higher quality levels and limiting liability exposure for the plastics converters. As you've seen, the shale play will have a major impact on how polymer is produced in North America. Understand that these same techniques will eventually be utilized in a rinse and repeat manner across the rest of the world. Now that you've heard about the market dynamics, I'm going to pass you off to Bill DeRoges. He will explain how our portfolio of instruments can provide you a window into your polymer process. Thank you, and I look forward to your question.
Thank you, John. In the next section, we are going to focus on a few important topics. Why do we need to test polymers? At what points in the process do we need to test the polymers? What are the benefits in each step? And how do we correlate lab information with production? Before I move on, I want to quickly introduce you to Dynisco's line of polymer test equipment. From left to right on your screen, we start with the LCR Capillary Rheometer. This instrument tests and simulates polymers at varying pressures, temperatures, and LOD ratios. The data generated with this instrument is the benchmark for evaluating polymers in the academic world as well as in production environments. Next in line, we have the LMI Melt Flow Indexer or Plastometer. This is used for quality control and verification of polymers to the ASTM and ISO standards. Next, we have the LME, TUS, and LEC. This is Dynisco's small extrusion compounding line that's used for making small batch developments of polymers. Finally, the last three instruments you'll see are Dynisco's online rheometers, which include the ViscoIndicator, the Viscosensor, and the CMR4. They are used to monitor real-time rheological data, correlating production data with that developed within the laboratory. As you can see in this slide, polymer is a blind product. In many cases, if it is a compound or repelletized recycled material, you can't tell the difference in the polymer characteristics by looking at it or feel confident with its specifications by knowing where you bought it from. With polymer being an extremely high expense for producers, the risk of not verifying rheological properties is great. Why do we need to measure polymer specifications? You want to ensure you are receiving what you purchased from a supplier before the material enters your process. Polymer tolerance can vary greatly between batch to batch and supplier to supplier. It is important you understand what works best for your product and your process. Second, are the process settings in your production operations set properly? This is important on two fronts. First, it ensures the polymer does not degrade and affect the quality of your product. Secondly, to help you with recycling of your own scrap, the correct process settings and verifications will minimize degradation. We'll talk about this more in a few slides. Recycling mandates of many corporations or industries require a certain percentage of recycled content. It is best that your reprocessed scrap or purchased recycled material is closest to your own virgin specifications to maintain quality. Finally, if regrind is being introduced, what is the maximum percentage of the regrind you can use without impacting your quality? It shouldn't be a guess or a random percentage based on history. If you can perform a simple analysis, you can dial in the proper blend ratio at the time of the production to ensure quality and maximize profits per part. Validating material at receipt in your plant. Many processes receive material in different ways. Some receive bulk material in rail cars or via trucks. Others order material in 25-kilogram bags. Regardless of how you receive the material, you will be mixing it or storing it with material previously received. An example of this is in a silo. Many processors will fill a silo when it reaches a certain percentage of fill. Just like in your car, you never wait for your gas tank to be empty before filling it up. What this means is your new batch of material being received is going to mix with 10 to 25% of material you already have in your system. If you find after the polymer is being used there are problems, as a processor, you will have a tough time explaining this to the resin distributor that the material was not contaminated in your silo or in your storage bins. With bags, it's easier to identify the rheological data of the individual bags, but globally, with the bag break systems that are being employed, you empty dozens of bags at one time or a full pallet of material. If you do this, you'll have the same problem mixing material in your material handling lines or in your day bins. A quick 15-minute test with a melt flow indexer while the material is being prepared to unload will eliminate this issue. When testing, it is also best to take a few samples from the top, bottom, and mid of a truck or a rail car. A few minutes of labor spent here will improve process consistency and save labor trying to identify issues down the line, or worse, reverse engineer failures in the field and the quality costs associated with that. Much like testing material before you receive it, within your plant you may contaminate lots before molding or extrusion. Within your process, it is important to select and test samples of your material at various stages so you can understand if at any point your process is having an adverse effect on your material. It also allows you to create rheological benchmark of custom blended materials. Many times, this is what makes your product unique. By understanding this data, you can measure the properties and maintain process consistency from lot to lot. Measuring this data will also help when designing mold simulation models for your parts. It is also important that you periodically test your product after it is molded to ensure that you are not degrading the polymer in the molding process. In the picture in the lower left, you'll see a typical example of a customer who has a runner part system where the runner has more material than the part itself. In this situation, you will have a lot of material being recycled over and over and over again. It is critical for the customer to understand if the process settings are appropriate so he can maintain this cycle of reusing the polymer. The molder is already granulating the runners, so taking a small sample and running it through a melt flow indexer will give valuable data to help the processor make adjustments or decision on regrind usage. Of course, by understanding the regrind being used at a specific time, you'll be able to adjust your blender percentage accordingly from each gaylord being supplied. When material is not properly vetted, there will be consequences in your end product. If melt flow isn't to specification, your part may be too brittle or too soft, and not hold tolerances or even meet design criteria. In the photo shown, you'll see an example of a crack in the polymer next to the threaded insert. This is an example of what happens when your melt flow isn't correct. You also may well hear after the shipment of quality issues in the field which could lead to warranty claims or lost customers. Take the opportunity to differentiate yourself from other producers of similar products. Understand your material as you're processing it. Online rheometers are excellent ways to take information used in lab environments and correlate them with production situations. Dynisco's online rheometers provide a continuous, real-time window into the process by measuring up to 15 different pieces of rheological information. These include melt flow index and ratio, intrinsic, relative, and melt viscosity, shear rate, shear stress, and shear sweep. These instruments reproduce data obtained from a melt flow indexer and a capillary rheometer in the laboratory and continuously monitor them within your production process. As you can see on the graph, the real benefit of measuring online rheology is when your process shifts, you can see immediately and assign an alarm condition, or have it corrected automatically by adding materials you know will bring your process back into a steady state condition. As you can see from this slide, Dynisco offers a full range of online rheometers to fit specific applications. From our ViscoIndicator, which indicates only the rheological data that your process has, to our Visco sensor and CMR4s, which do full indication and control of the rheological data. The Rex option provides the process the ability to take pellets, re-extrude them, and then measure the rheological data. The last topic I would like to talk about is how melt flow indexers and online rheometers can assist post-industrial recyclers. Recyclers have the task of procuring post-industrial scrap from processors, size reducing it, and finding customers for the reprocessed material. Polymer analysis in these environments is extremely important so that the recyclers can make smart purchases on the incoming material and get the most money per pound when they sell it. In a market where small change in price per pound can make a significant impact to profitability, a simple tool like a melt flow indexer can pay for itself in a matter of weeks. Understanding the rheological properties of the material can contribute to the profitability of a recycling operation. Typically, a recycler will purchase large batches of material that will allow them to process the same scrap over time, minimizing the changeover and cleaning time between materials. If a recycler understands what they are purchasing in advance, it will allow them to find a buyer for the material after it's recycled. or even make sure the material is not degraded to the point where it's not usable before they purchase it. Many recyclers have bought material and then are burdened with it, unable to find a buyer. The post-sale benefit lies in the concept of certified material. Some recyclers have moved to the point where they supply their own material data sheets on the material they have reprocessed. By providing material certifications, it significantly improves their ability to sell the material to a wider audience. With a small investment, a recycler will be able to provide the end user with data of what they're buying, giving them additional confidence and making sure they may have made a sound business decision. Next, you'll hear from John Cazzati, Dynisco's Director of Engineering. He will go into the technical details of Dynisco's online rheometers, especially the new ViscoIndicator, which will help bring online rheology to all processors.
My goal is to explain how the ViscoIndicator Online Rheometer duplicates the test conditions of a laboratory melt flow index tester or capillary rheometer. Melt viscosity measurements, such as the melt flow index or MFI, are primary specifications of thermoplastic resins. MFI and melt viscosity are related to polymer molecular properties, so these numbers give some measure of the physical properties of their product as well as the polymer processability. MFI is a measure of the ease of flow of the melt of a thermoplastic polymer. It is defined as the mass of the polymer in grams extruded in 10 minutes using a specified test method such as ASTM D1238 or ISO 1133. In the method, polymer is heated to a defined temperature. Then it is driven through a capillary with a defined diameter and length by pressure created by loading a piston with a defined weight. The pressure in psi would be the pounds of the test load divided by the area of the piston in square inches. The weight of the material driven out of the capillary by that pressure in 10 minutes is that material's melt flow index, or MFI. The melt flow index test is a very simple and effective way to check material viscosity. Because of the short capillary L over D, this rheometer measures not only viscous losses in the capillary, but also viscoelastic losses in the capillary entrance. This means that the measurement is a function of both the rheometer geometry as well as the polymer viscosity. In other words, the ASTM D1238 standard defines both the apparatus and the polymer test conditions. Melt flow indexers must be hand-loaded with pellets and weights to create shear conditions, so the test requires a technician and must be done offline. The ViscoIndicator simulates both the apparatus and test conditions of the MFI test right on an extruder. In the model of the ViscoIndicator you see on this slide, a side stream is taken from the extruder as indicated by the red text in the top center. Process pressure from the extruder forces polymer melt into a metering gear pump. The pump then generates the flow rate and the pressure to extrude the polymer through a capillary. The temperature of the steel around the capillary and pump is controlled. A single pressure transducer is located above the capillary to measure driving pressure. The test polymer extrudes to atmosphere. By that I mean it falls to the floor, just like it would in a melt flow indexer. All material that enters the rheometer flows out as scrap, typically at the rate of 1/2 kilogram per hour. This rheometer duplicates the internal geometry of the melt flow indexer, so the capillary entrance effects are similar. In the ASTM mode of operation, the pressure defined by the load and piston specified in the ASTM method is recreated by controlling the gear pump flow rate using data from a pressure transducer. The material flow rate is calculated from the speed of the gear pump. Remember that a gear pump is essentially a positive displacement device that pumps the melt at a constant rate regardless of the resistance to flow. So by measuring the gear pump speed required to control pressure at the ASTM set point and knowing the pump flow rate, the ViscoIndicator is able to calculate MFR directly as a function of the pump RPM, given that flow density is known. If you don't know the flow density of your polymer, you can easily measure it using a standard method on a melt flow indexer. This is how a ViscoIndicator duplicates the test result from a melt flow indicator right at the extruder without needing a technician. The ViscoIndicator has a Windows 10 IoT, or Internet of Things, based rheological software platform that leverages the power of Windows 10. IoT devices running Windows 10 can make use of many other Microsoft services for a better user experience and control. Windows 10 IoT provides an interface that is familiar to almost everyone. Operators will find this much more intuitive than some of the PLC ladder logic-based interfaces. They can navigate around, set up, and do things that would prove difficult or confusing on other platforms. It also has the advantage of being easy to set up on a Windows-based network. Since ViscoIndicator is Windows-based, the basic setup is the same as that as all other devices running on the network. In addition, ViscoIndicator allows you to collect and store process data on internal or external storage. As you can see on the slide, the ViscoIndicator has the look and feel that would be familiar to most shop floor personnel. Why is this important? It lowers the training time to become effective in measuring the rheological properties of your polymer process. This, along with the ease of connection I'll be describing in the next few slides, gets you up and running in a minimal amount of time. This slide shows the ViscoIndicator rheological head on its stand. The ViscoIndicator has a small footprint for ease of delivery and setup. The rheological head is easy to install into the extruder because it can be connected using a standard pressure process connection. The side stream of material that the ViscoIndicator measures is not returned to the process stream. This slide shows the internal features of the rheological head. As you can see by working from right to left, material flows in from the process, then out from the pump into a chamber where it is measured by the pressure sensor. The pressure sensor is a vertex, allowing for high accuracy measurement of the low pressures typically created by the test load during a standard melt index test. Standard pressure sensors cannot make this measurement in a half-20 pressure port as well as the vertex does. Some processors extrude a variety of materials. ViscoIndicator allows for a quick change of capillary. The capillary can be pushed out by removing the port plug and the screws from the capillary retainer. There is no need to remove any other hardware. The rheological head must be supported. It can be supported by securing the mounting bracket to the extruder directly or by using the ViscoIndicator stand. The stand can be configured to allow the head to mate to the extruder in various sensor mounting hole orientations. As you can see, ViscoSensor adapts to your extruder. ViscoSensor includes innovative software and hardware to enable viscosity measurement on an extruder at the low cost that will allow you to realize a significant return on your investment.
Okay, John, Bill, and John, thank you very much for all that great information. Now, I'd like to move on to the Q&A session, but before we do, I'd like to remind all of our audience attendees, if we don't get to your question, don't worry. We'll have an answer for you following the webinar. The complete Q&A transcript, including answers we don't have time for, will be sent to all of our registered attendees and will be posted with the webinar when it goes into the on-demand mode. Okay, let's move on to those questions. Our first question looks like it's for Bill. You talk about the ViscoIndicator in terms of being rheology for the masses. How is it different from other online rheometers?
What differentiates the ViscoIndicator from other online rheometers is that it's designed for easy installation and use across all extrusion processes. Its ability to connect to existing process connections and a simple plug-in intuitive control system allows every process to access this critical rheological data at an affordable price point.
Okay, thanks very much, Bill. It looks like the next question is for John Biagioni. John, what do you mean by material genealogy?
Great question. Material genealogy references a histogram capturing the actual physical properties of the materials as they are processed over time. This provides full lot traceability from start to end, ensuring your process is not negatively impacting the molecular weight of the material being processed.
Okay, thanks very much, John, for that answer. Next up, it looks like we have a question for John Kazati. Does the ViscoIndicator measure viscosity?
Yes, it does. For the purposes of this webinar, I specifically spoke to the melt flow index test. By controlling pump speed instead of pressure at the capillary, we can measure viscosity as well.
Okay, John Kazati, here's another one for you. Why just indication versus indication and control?
From our discussions with customers, many told us they were looking for just a histogram without the complexity of controlling the process. Melt flow index and viscosity ties back to the melt flow indexer or plastometer, allowing for both sampling and run rate data, ensuring quality. If you're looking to control the process with this data, Dynisco offers the ViscoIndicator and CMR rheometers. These both tie back to your DCS.
Okay, thanks very much for that answer, John. Bill, it looks like we're back to you. This one's for you. Do I have to buy the stand for the ViscoIndicator, or is it included?
When you purchase a ViscoIndicator, it includes a rheological sensing unit, a control cabinet, universal cables, and a U-bracket for customer mounting, along with a 7-inch touchscreen HMI. The stand, among other items, is an additional accessory available for purchase.
And thanks very much, Bill. Here's another one for you. Where can I see the product running?
We will be launching the ViscoIndicator at the upcoming CADE show, taking place on October 19th to 26th in Dusseldorf, Germany. We are located in Hall 10, Stand 10C19. Additionally, at the end of this webinar, there will be a survey distributed out, and upon submission, you will be automatically entered for a chance at a 60-day beta trial of the ViscoIndicator that includes free installation and freight.
Okay, great. Thank you very much, Bill. Now we have time for one more question, and Bill, it looks like it's another one for you. If I have online measurement, why do I still need lab equipment?
It is still critical to have lab measurements that correlate back to ASTM and ISO standards. All online rheometers correlate to that data, but you need to have benchmarks that tie back to these. As I previously stated, a melt flow indexer inspects and qualifies material pre-processing, while online rheometers validate this data through the process.
All right, everyone, we're going to have to wrap up this webinar right there. John Biagioni, Bill DeRoches, and John Kazati, I want to thank you all very much for sharing your expertise with all of us today. So thank you so much for being here. And a special thank you goes out to all of our audience members for being part of this webinar event. Take care, and we'll talk to you soon.